This video is a review for options, and we're going to use exercise from homework 4 to drive the review. Now, first, the intrinsic value of the call option and put option is given by the formula, which you can use this max function in Excel and get the intrinsic value here. And to calculate the profit or loss on the call, then you need to add one more thing. So the cost for buying the call option. So you need to subtract C here. C here represents the option price. And the profit on the put will be this max function bracket exercise price minus the stock price, whichever is higher, either 0 or X minus the stock price. So here, the first part represents the intrinsic value of put, and the second part of here minus P. P here stands for the option price for put. So you need to pay the price of P in order to buy a put contract. So we're going to use this profit function for call and put later. So this will be a function, a formula that will be always used for option calculation for the profit. And then we're going to also talk about option arbitrage proposition. These propositions set up the option price, arrange for the option prices such that there's no arbitrage opportunity out there. So each of these propositions represents some fact about option prices. It is derived without any assumptions about stochastic process of stock price, meaning that you don't need to make any assumption about, for example, the distribution of stock price and how stock price may fluctuate over certain time periods. You don't need to make any assumption about that. So no assumption needed. Just by definition, call and put, if we have the definition of call and put, and therefore we should have these kind of propositions out there. And what are those propositions? Let's look at proposition 0. It sets up a lower bound for the call option price. Let's consider an American call with option premium C0, exercise price is X, and the stock price now is at 0. Therefore, the option price has to follow this lower bound. So it cannot fall below the maximum between stock price minus exercise price, or 0. If this one is negative, so stock price minus exercise price is, if this one is negative, then the option price cannot drop below 0. And the proof will be very simple. So let's say if this proposition is violated, then we will have here, the example here has stock price equals to 50, exercise price equals to 40. Then S0 minus X will be $10. And the call price is $5, so obviously $10 is not less than $5. So this proposition is violated. Then what we can do here is to construct a strategy to make immediate profit. So how do we make immediate profit? You're going to buy a call with exercise price, which is very low, 5 years. So pay $5 for buying a call so that you have an option to exercise at $40, to buy the stock at $40. And since it's American option, you can exercise it early. So you can exercise it immediately, pay $40 to buy the stocks. And then what you can do simultaneously is that you can go to the stock market and sell the stock, short sell the stock immediately. So you will receive $50. Since you buy the stocks here, so you have the one share from here, one share from here, borrow it. So these two shares can cancel out. You can return the share with the share that you bought here when you exercise in the call option. Now the gain for this activity will be a plus 10% gain. So sell the stock immediately, exercise the call option, you have $10 gain. And subtracting the cost for implementing the strategy, which is buying the call, subtracting 5, you will have a $5 positive gain with no risk. Everything will be done simultaneously and also immediately. So there's no risk exposure, but a positive return, a positive profit. So that's proposition 0. If we just make some very simple extension, let's say the option cannot be exercised early, meaning that there is some European option. So the exercise price is therefore some price that you will realize in the future. So the present value, so we need to therefore consider the present value of X. So therefore, the lower bound for C0 here will be X between the current stock price subtracting the present value of X. So our exercise 1 here is about proposition 1. So what we'll have here is there will be an American call option written on a stock whose price here today is $50. Exercise price is $45. And if the call price is 2, explain how you will use arbitrage to make an immediate profit. And if the option is exercisable at time t equals to 1 year, if the interest rate is 10%, what is the minimum price of the option? So go ahead and look at the question here. So now first, explain how would you use arbitrage to make an immediate profit. So we want to make an immediate profit, meaning that we want to exercise, so we want to obtain the profits now. So let's see if the call price violates the proposition 1 first. So the proposition 1 is trying to say that 50 subtracting 45, $5, is it larger or greater than the call price? So obviously, the call price is 2, it's less than $5. So $5 is the, according to here for American option. So you have $5 on the left-hand side, $2 for the call, meaning that this proposition is violated. So what you can do is to buy the option and exercise it immediately. So you will pay $2 to buy the option, exercising it, then you'll get a $5 gain. So these to add up, you will have a $3 gain. That's a pure gain. So here, what you need to do is simply buy the option and exercise it immediately. So next, if the option is exercisable at time t equals to 1 year, so what should be the minimum price of option? So we're going to use the formula here for proposition 1. So we're going to calculate the max between the current stock price subtracting the present value of X. Now here, if the interest rate 10% is log return, then what you need to do is to use X, the exercise price, times EXP, and negative R times T. T here is 1 year, so it will be 1. If this 10% is simple return, so what you can do is just divide it by 1 plus 10%. Based on different assumptions for 10%, since the question does not set this 10% is log return or simple return. So there are 2 ways of calculating this minimum call price. Okay, going down to arbitrage proposition 2. It is never optimal to exercise the American option early for call, and the underlying stocks will be a stock that does not pay any dividends before the option maturity, time t. The interpretation of this proposition 2 is early exercising the call will be never showing any better profits than selling the call. So you can have, if you want to close your position for this call contract, you have 2 different ways of closing it. One is to early exercising it, and another way of closing the position will be just selling the call at the call's market price. If selling the call is more profitable, giving you a higher price than exercising the call, then no one will exercise it early. Here, a simple proof for proposition 2. We're going to use proposition 1 as well. So let's say we own a call with half a year to maturity, exercise price is $50, stop price is 80, interest rate is 6%. Early exercising the call option will realize the $30 difference between the exercise price and the stop price. So you'll realize this $30 profit. And by proposition 1, the market price of the call will be at least the maximum between S minus PBX, the present value of X. So it's going to be $80 for the stop price minus the exercise price times the discount factor, which will be EXP raised it to the power of negative 0.5 times 6%. And that will be the call price. The market price of the call will be 31.45 cents. So roughly $31. So you can sell the call at $31. And here, another way of closing the position is exercise the call, and you only gain $30. So therefore, it will be better off to sell the call than exercising it. So no one will early exercising it, since this way, another way of closing the position dominates the way which will ask the investor to exercise it. The intuition, or how can we interpret proposition 2? So you're going to see that American option, it has a feature for the calls that does not pay dividends. That those features is often worthless. The feature is specifically pointing to the early exercising option. In many cases, American option and European option, they have the same value, as long as you can see that the underlying assets does not pay dividend and they are on the call contract. But it's not the true for put, and we're going to use to exercise to demonstrate that. So we're going to use exercise 5 and exercise 6 to show that for call, you can see that it is never optimal to exercise the call option. For put, you're going to see that from the graph. You're going to plot intrinsic value, which is shown by this formula, and also the Black-Scholes price, which is an indicator for the market price of option. You're going to see that for put option, it may be sometimes it is optimal to early exercise the put option. So meaning sometimes the Black-Scholes price is lower than the intrinsic value of the put. So we're going to look at the exercise now. The exercise is built on exercise 4. You're going to calculate the call price and put price here for exercise 4 using these parameters. So stop price is 50, exercise price is also 50, so it's at the money option. Interest rate 10%, time to maturity 0.5, so half a year. Volatility of the stock is 25%. This is necessary for calculating the Black-Scholes option price. So you can calculate it in 2 ways. I'm going to use the user-defined function to calculate it. I'll just copy the user-defined function for Black-Scholes call price and Black-Scholes put price. And the first element to input is the stop price, exercise price. Second one is exercise price. Third one is time. Fourth is interest rate. The last one is volatility. So I have it here. So I'm going to calculate Black-Scholes call, stop price, exercise price, time to maturity, interest rate, and sigma. And Black-Scholes put, stop price, exercise price, time to maturity, interest rate, and volatility. So next, you need to produce a graph comparing a call's intrinsic value and its Black-Scholes price. So here, everything is for the, so S here is S0, is the current stock price. It will fluctuate in the future. So meaning that the option's intrinsic value will be changing according to the price of the stock. And Black-Scholes price will be also changing since S will be. Now I'm going to do a data table to calculate this Black-Scholes value for call. And for the intrinsic value, I'm going to use equals to max dot price exercise price and fix it. F4. since it's call, so it should be this one, drag it all the way down. And I think I missed this 0. It's not profitable, so people wouldn't exercise in it. So you wouldn't get a negative number. Okay. Now I'm going to do a data table. What if analysis, data table. The column input will be the stock price. Okay. Refresh it. I'm going to plot these two. Okay, so then how do we use this graph to show that it is never optimal to exercise the call option early? So you'll see that the intrinsic value is always below the black shows price. So it will be always better to sell the option, realizing the black shows value, and to exercise it early, in which case you would get the intrinsic value. And moving to the next one for exercise 6. So this time you want to look at the put option prices. So everything, all the parameters will be the same. I will just copy the parameters here. Now, data table will be targeting at the put price equals to the put price here. And this will be the max between exercise price subtracting stock price. With this graph showing you the put intrinsic price given by this orange line, and the black shows put value given by this blue curve, you're going to see that when stock price is low at this range, the black shows price is less here, is less than the intrinsic value. So if someone can exercise it early with American option, the option will have increased value. So early exercise may be valuable for put. So now we have discussed question 4, 5, and 6. So let me just go back and we can move on to proposition 3, and that will be relevant to question 2. Proposition 3 here is about the put call parity. So we'll consider an American option. So for put and call on the same stocks with same exercise price, X, and same maturity day, the stock pays no dividend before option exercise day. So the put and the call here, in this case, with same exercise price X, should have the price of put and call P0 and C0 should follow the put call parity. So the put call parity meaning that here the price of put plus stocks should equals to the price of call plus the present value of the exercise price. If you found that put call parity does not hold, then there can be an arbitrage opportunity out there. And we'll discuss that with the exercise here. So the exercise here that we have is an European option with a maturity date of 6 months and exercise price X equals to $80. This is written on the same stocks currently pricing at the price of the stock is $85. And the call is selling for $12. The put is selling for $5. So put has the same maturity day and same exercise price as the call. The interest rate continuously compounded, meaning that this is a log return. So 10% is a log return. So we'll need to first look at whether the put call parity holds. If it does not hold, if it's violated, then we can construct an arbitrage from this situation. So first, calculate the present value of X. Since 10% in the question, it's continuous compounded, so we need to use $80 exercise price times EXP, raise it to the power of 10% times maturity day. And call plus X, present value of X will be equals to the call price, $12 plus here, and put price plus price. Put price is here, $5 plus stock price, which is 90. So on the left-hand side, we have put price plus the stock price, and that equals to $90. On the right-hand side, we have cost of the call and the present value of exercise price. That will be $88. So $88 on the right-hand side does not equals to $90 on the left-hand side, so put call parity is violated. Therefore, we can discuss about how to construct the arbitrage opportunity. So I actually give you the hint. So what we'll need to do is to establish 4 different positions. The first is to write the put. So you can get the left-hand side, you need to, so here, since our right-hand side is 88, so you will need to buy 88, taking long position of the right-hand side, and then taking short position of the left-hand side. So you will receive $90, and you just need to pay $88 on the right-hand side. And these cancel out so that you have a pure gain of roughly $2. So you have $2 pure gain here, according to the put call parity. How to exploit this price difference, $88 versus $90. So what you need to do is to get this $90 on the left-hand side, and then during the same time, pay $88 on the right-hand side. So these 2 positions, so we'll close out, so we'll cancel it out, and you'll have a pure $2 gain. So how to obtain P plus S0? So for obtaining P0, so obtaining the option, the put option price, so you need to take a written position for put. So you will write the put here today, and to receive S0 today, you need to short sell S0, so short stock S0. And here on the right-hand side, you want to have the call, buy the call, pay C0, and also pay present value of X. So here for the first position, writing the put, so you need to establish it today. So what you can get is the put price. Shorting the stock today, so what you'll get is the current stock price, 85. Buying the call, you get you need to subtract the call price for buying it. And for buying the bond, you need to pay the bond price, which is 76. Negative 76. So in the future, so since you will lend money to others, so in the future you will receive the amounts that you lend. So $80 in the future, $80 in the future. Comparison between and the exercise price. So for bond, comparison between, it's just your investment into the bond, so it's not going to be fluctuated depending on the price of the stock. So it will be always $80. And currently you'll pay $76, and in the future you'll get $80 back. So the difference will be the interest rate. And then for shorting the stock, so now you receive 85, and in the future you will get ST So you will receive $85 today, and in the future, you will pay back the stock price. So you borrowed one share, and that price for the share today is 85. In the future, you need to return that one share back with the future stock price, ST. And then for buying the call, so if ST is less than the exercise price, so no one will exercise it, so the call has zero value. If ST is greater than the exercise price, so people will go for the exercise price to buy the option too. So therefore, they will exercise the call option. So what you will get will be the difference. So your profit, the intrinsic value, will be the difference between the stock price and the exercise price. For writing the put, so since you take a written position, so everything will be negative of, in this case, people will exercise the put option. So your the people who take the long side will exercise the call option, will exercise the put option since the exercise price is larger. So the selling price for the put is larger than the stock price. So they will exercise it. So you need to pay the difference between exercise price and the stock price. Here, no one will exercise the put since the stock market has a better price to sell. So it's going to be 0. So now let's say today, the total profit of this 4 different positions will be just the sum of all of these positions. So the sum of all of these positions will be giving you a $1.9 pure gain. And in the future, if stock price is less than the exercise price, so adding all these together, so you have negative 80 and positive 80 here cancel out. And here you have a positive ST and a negative ST cancel out. So you have 0 in a case when the stock price is less than the exercise price. When stock price is greater than the exercise price, you have negative ST here, positive ST here. So cancel out, negative 80 and positive 80 cancel out. So you have 0. So the arbitrage will be given by this 4 different positions. So you need to pay. So in the future, you will have 0 loss, 0 gain. But today you can get $1.9, roughly $2 here from this 4 different positions. And this is what we call arbitrage. So you don't have any risk here, but you can have a positive profit. Now going further to question 3, this is actually about the call price convexity and put price convexity. And I will have to have you spend a little bit more time on reading the chapter 15.6 about this arbitrage proposition and what it is and how to prove it, how to establish arbitrage opportunity to prove this proposition 5 and 6. Proposition 5 is about call price convexity. Proposition 6 is about put price convexity. So the basic idea is that if you know the option strategy well, so there will be an option strategy called butterfly that will be using 3 different calls, either 3 different calls or 3 different puts. So the way of arbitraging from the if this proposition 5 is violated, the way that people will construct the arbitrage will be using the butterfly strategy. The basic about butterfly strategy is that, so you want to combine 3 puts or 3 calls with different exercise prices. So they should not have the same exercise price. So they will have different exercise price. Like in this case, you have 3 different calls. The exercise price is 30, 40, and 30, 20, 30, and 40. The call price is $10, $6, and $4. And the number of the positions, so there will be some short position and some long position. And the number of the position should add to 0, meaning that if you want to sell 2 call options here, then you want to buy 1 call 1 and 1 call 3. So therefore, they add up to 0. In this case, if you want to sell 2 call 2, so you have you will be selling 2 call 2, and then therefore you need to buy 1 call 1 and 1 call 3. And the profit, the payoff pattern looks like a butterfly, so that's why the strategy is called butterfly. Now then, how do we use butterfly spreads to basically prove proposition 5? The proof of proposition 6 will be very similar and will be illustrated in our exercise. So if proposition 5 is violated, so proposition 5 is saying that there will be 3 calls with 3 different exercise price, and they are equally spaced, meaning that the exercise price 2 will be the average of exercise 1 and 3. So let's order 3 different calls in this way, so that such that call 1 has the lowest exercise price and call 3 has the highest exercise price. So the option price of call 1, 2, and 3 should follow this convexity here. If it does not, then we'll use the arbitrage. So we're going to use the butterfly. So we'll have 20, 30, and 40, 3 different calls with 3 different exercise price. And the call price is here, 10, 6, and 4. And let's see whether call 2, so call 2 is 6, and the average of call 1 and 3, the average price of call 1 and 3 will be 14 divided by 2, that will be 7. So 7 is larger than 6, so there's no arbitrage opportunity out there. Let's see if what we can do for the profits, the total profit of this butterfly strategy will be shown by this pattern. So you can sell 2 calls for call 2 and buy 1 call 1 and buy 1 call 3. You're going to see that there's no arbitrage here. Arbitrage meaning that you always have a pure gain, you always have positive return. So here, sometimes you have a negative, you'll lose some amount of money for buying call 1 and 3, and some other times you have you can win. So this is saying that is, there's no arbitrage here. Let's say if the call price set up in another way, that it violates the convexity. So in this case, we have call 2 equals to $8, and the average price for call 1 and 3 is $7. So $7, okay, $7 here on the right-hand side is not larger than $8 on the left-hand side. So let's see what happened for the butterfly strategy. So the total profit will be shifted upward. So that means you will never lose. So no matter what the terminal value of stop price is in the future, so it can fluctuate from 0 to 70, it doesn't really matter. Then what you obtain from the butterfly strategy is always some positive value. Sometimes it's even bigger if it falls in this range. But even if go to very low price, even the stop price drop to some very low price or increase by a large amount, you always have a positive gain. So this is arbitrage. So this is for call. So for put, if you look at the chapter, you're going to see that book price should also follow the convexity proposition here. So I will need to copy to exercise 3. And I will need to move this 2 to the left-hand side, since if we want to make this, since it's hard to buy half of the put contract, but we can instead double it. So we can buy 2 put here on the left-hand side. Okay, so for the question, there will be 3 different puts on the same stocks with same expiration date. So 40, 50, and 60 means their exercise price. 6, 4, and 1 shows the put price for buying this put contract. And let's see if the proposition is violated or not. So this is proposition 6. So we're going to use 2 times put 2, 2 times 4. On the right-hand side, it's put 1, which is 6, plus put 3, which is $1 for buying put 3. So therefore, let's see if here is less than this, then true. Okay, so therefore it shows that proposition 6 is violated since if you buy two, put two here, so buy two contracts for the put with the exercise price equals to $50, you need to pay $8. And if you buy one, put one, and one, put three, you need to pay $7, and $7 is not larger than 8, so this proposition is violated. So then we can talk about how to construct arbitrage strategy. So the arbitrage strategy is about the butterfly still for constructing the butterfly strategy. And now we want to get, so if everything holds, then, we have this left-hand side is less than the right-hand side. Now, if it's violated, so what we can do here is to exploit this 8 and pay only 7 so that we can have a gain of 1. So then how do we get this 8 on the left-hand side? So that means you need to write two put contracts with the exercise price equals to $50. And then you can buy two put contracts with exercise price equals to $40 and $60. So the prices violates the convexity arbitrage proposition, which says that 2 times put 50 should be less than put 60 and 40. Thus, an arbitrage strategy is to sell 2 of the 50 put so that you can get the left-hand side, which is 8, and to buy a 40 and a 60. So here, let's do this. So we need to sell 250 put. So you will need to sell what we have here. Okay, X minus, X will be 50 minus ST. ST will be here. Subtract the put price, which is 4. I'm going to use 2 times this since you will sell 2 of the 50 puts. So selling meaning you have a negative sign here. And plus, so since we want to know the profit of the strategy, so you're going to be plus buying 40 put. 40. Price for the 40 put will be 6. And also buy a 60 put. 60. The price for the 60 put will be 1. So then drag it all the way down. Make a diagram. So how to show that the strategy allows you to profit from these prices and prove that it works? So we show you first need to specify or explain how the strategy will work, and then show the profit for the strategy and explain it in a way that here profit is positive no matter what the stock price is at time t. So this will be an arbitrage. Now, this should conclude these couple of propositions. I again strongly suggest that you will, I strongly suggest that you read the textbook chapters. So the final things about this Black-Scholes, the final things about the option chapters is about Black-Scholes model. So here's the Black-Scholes model. You need to first know how to calculate option prices based on the model. And then you can also you should also know how to use Black-Scholes model to calculate the implied volatility. So implied volatility formula, implied volatility cannot be solved by the formula. It can only be calculated using a try and error method. So you need to use a VBA function in Excel to find the value for the implied volatility. So there will be a function for finding the implied volatility of call and finding the implied volatility for put. In question 7, this is a question about the implied volatility and about the price of the option. So you will have the table in the Excel file for the option on American Airlines. So the option has an exercise price equals to 27.82, and this is assumed to be the at-the-money option, meaning that the current stock price is also at 27.82. So first, calculates the implied volatility of each option using the function call volatility and put volatility. And then graph these volatility to see if the volatility shows a smile. Copying the code for the user-defined function of calculating implied volatility for call and also for put. So the first elements you want to input is stock, and then exercise price, time, interest rate, and also the target. Target here is the market price of the call. So we're going to set Black-Scholes price equals to the market price of the call, and then back out the implied volatility and back out the sigma that we'll use in the Black-Scholes model. Equals here equals call volatility, stock price, exercise price, time to maturity, interest rate, and the market price of the call. Enter, drag it. I need to fix here, stock price, time to maturity, and plot implied volatility against the strike price. Okay, so now that you can decide whether the volatility looks like a smile. Now going to exercise 8. Re-examine exercise price equals to 70 for that call contract. Is this call correctly priced? The second question is, what price would be necessary for this call in order for implied volatility to be 60%? So let me just copy the formula here for calculating implied volatility. And the implied volatility here for $70.50 option is 0, meaning that this price cannot be right. So the price for this option cannot be right. Since every other parameters, this is stock price, right? And this is the maturity day, interest rate, strike price, these are all standardized. And the option price here, something wrong with the option price. Now, what should be a good option price here? Let's look at the volatility the range of the volatility here. It's somewhere from 40% to 80%. So we're going to go from 40% all the way to 70% and calculate the Black-Scholes price. Stock exercise price time to maturity, interest rate, and volatility. So what price would be necessary for this call in order for implied volatility to be 60%? If you want implied volatility equal to 60%, then the call price has to be here, $10.92. Now the previous price, the call price for the exercise price equal to $7.50 is too low, which is why the function for implied volatility gives 0%. That's implied. And now we can also utilize the proposition for call price convexity. So in order for call price convexity hold, the price of the 17.5 call has to be less than 13.5 plus 8.4 divided by 2, which is 10.95. Given proposition for call price convexity, the maximum call price for this 17.5 call cannot go over $10.95.